Today we are going to see about the Maxwell's first equation. Maxwell is given the four equations to explain the mathematical relation of electric and magnetic field as electromagnetic waves. So among the four equations, we'll be discussing about the Maxwell's first equation in detail. The Maxwell's first equation is given by del dot D vector is equal to rho. Here the D vector is nothing but the displacement vector. D vector is displacement vector, that is the displacement of charges on the application of electric field, and rho, it represents the charge density. Okay, and next we'll be finding this del dot D vector is equal to rho, how we arrived at this equation. Now starts with the Gauss law for electric field. So we can solve the Maxwell's first equation from applying the Gauss law for electric field. Yeah, Gauss law for electric field is given by total electric field vector within a closed surface. It is equal to 1 by epsilon naught times the total charge. Here the epsilon naught, it is the permittivity of free space. Here the total electric field within a closed surface is equal to total charge per epsilon naught. For example, within a closed surface, if there are so many number of charges, and that electric field vector within the closed surface is equal to the total charge divided by epsilon naught. Here the epsilon naught, it is the permittivity of free space. Now we are going to find the Maxwell's equations using this Gauss law for electric field. Let us that be the first equation. From this first equation, electric field vector, which is equal to q by epsilon naught. This is the first equation. From this we'll be solving and getting the Maxwell's first equation. Here epsilon naught in the other side, in the right hand side, is taken to the left hand side. It comes as multiplication. So surface integral epsilon naught E vector ds is equal to q. And we know that a displacement vector is given by the equation epsilon naught, epsilon r, and E vector. Here epsilon naught is a permittivity of free space and epsilon r is a relative permittivity. Here we'll be applying this displacement vector is equal to epsilon naught, epsilon E. Here epsilon r is equal to 1, that is relative permittivity for air medium. It is considered as a value as 1. On substituting this in the above equation, displacement vector is equal to epsilon naught E vector. Here D vector is equal to epsilon naught E vector. Let us take this as the second equation. And the previous equation, it is, let us be A equations. So substituting this 2 in the A equation, in place of epsilon naught E vector, we have to substitute as D vector. ds is equal to the total charge, capital Q. The total charge, it is given by the equation volume integral of charge density. So volume integral of charge density. So when we are putting the volume integral, the dv, it comes as default, and surface integral, it is ds. This is a Maxwell's equations in integral form. And next, using this, Maxwell's equation in differential form can be found. So by applying the integral form of a Maxwell's first equation, here we are going to simplify the left hand side term. From this left hand side, we are choosing this left hand side term. Surface integral of d vector dot ds it is converted into the volume integral from Gauss divergence theorem. So by applying the Gauss divergence theorem, here the surface integral is converted into the volume integral by substituting del dot d vector. So d vector is taken as divergence of d vector. So this is what said in the Gauss divergence theorem. So surface integral is equal to del dot d vector into dv. So here by applying the Gauss divergence theorem, surface integral is converted into the volume integral. On substituting this in the previous equation, in place of the left hand side term, the surface integral converted into the volume integral by applying the Gauss divergence theorem, del dot d vector dv is equal to volume integral of the charge density. Now on both the sides the volume integral is same, so the integrands are same. The volume integral is cancelled on both the sides. We get del dot d vector is equal to rho. So this is a Maxwell's equation, that is a Maxwell's first equation.